Alright, in today's video we're going to be going through the section 3.2 worksheet. So this worksheet is on more confidence intervals. We're going to learn a couple things. We're going to be focusing mostly on a single proportion. So every time we see statistic, we're going to be talking mostly about p hat. The first couple examples with converting in notation, we'll use a little bit x bar and some means, but for the most part in the later examples we're going to be using p hat. Just in this section, section 3.3 we'll do means. So we're going to build on 3.1 where we made some confidence intervals by just testing multiple null hypotheses and either rejecting or saying they're plausible. So today what we're going to do is learn two ways to create these intervals, but it'll be a little bit nicer than having to kind of run through and check and check and check. So before we get started with that, we should go through and try to work on making sure we're confident, no pun intended, with the ways that we could write these intervals. So for example, the way you'll see these intervals written sometimes is statistic plus or minus the margin of error. So again, remember the confidence interval is a way for you to say, I think the answer being the population parameter, is this. But I don't have complete information because we never do in statistics. So I might be wrong. And the amount I think I'm wrong by is this, possibly, is this margin of error. Now, could I be right? Of course. But there is always that extra randomness, that not sure. So that's what this margin of error does for us. So in our case for proportion, this would look like p hat. I'm going to add and subtract to that the margin of error. Now in class before break we were talking about how this margin of error seemed like it might have something to do with the sample size and some other information. So we'll get into that a little bit later. This would be for a proportion. I might also have a mean where I have the statistic now as an average, x bar, plus or minus some margin of error. And again, we'll get into these formulas in just a second. So in the other way we saw these confidence intervals, the way that I was having you write them before break, was not necessarily this way, but instead was as a range. So a low to high. And remember, the way we had defined this was these were all the plausible values. So plausible values, where the smallest, the low, would go to the left and the biggest would go to the right. And that's how we had done it together in class. And we'll do an example of that in just a second to remind us. But really, if we combine these formulas, this is the same thing as, we'll just do the proportion example, p hat minus the margin of error, p hat plus the margin of error. These are really the same exact thing. Your low and your high are going to be these two calculations. So then we can just go back and forth between these things. So just as an example, let's go to example 1. So it says we have a p hat of 0.62 and the margin of error is 3.2%. So when we do this, what we're going to do is just going to use the formula. So let me scroll up so we can see it still. The formula is p hat plus or minus margin of error. So then for us that's 0.62 plus or minus, and what I'm going to do is I'm going to convert this percentage here into a decimal, 0.032. Remember, that's just take the decimal place, move it twice to the left. And then what this notation says is, okay, add these two numbers, put that on the right, subtract these two numbers, put that on the left. So in my calculator I'm going to do 0.62 plus 0.032, and I end up getting 0.652. Okay, that was when you're doing the plus. And now on the left I'm going to do the minus. So this is me now doing the minus. 0.62 minus 0.032 is 0.588, and that's my confidence interval. So both of these are confidence intervals. They're just two separate ways of writing them, but they say exactly the same thing. Okay, so a similar example, we can do this now, but with an average, a mean. So that would be x bar plus or minus the margin of error. So again, just to keep reiterating this, this is my guess or my best estimate to the population parameter. And this tells me, well, I could be off, you know, I could be underestimating it or overestimating it. And this margin of error gives me an idea of how far off I am. So I'm going to plug in my numbers, 115 plus or minus 4.5. Okay, this is one way of writing the confidence interval. Check. Okay, but I could also write it in the actual interval notation. So that's the minus, the plus side. Okay, I'm going to do 115 plus 4.5 is 119.5. And then I'm going to do 115 minus 4.5, which is 110.5. All right, there we go. Okay, oops. So then example 3, now in example 3 what we're doing is we're just going the opposite direction. So in this direction, they've actually given me the interval. They're telling me the population parameter, mu, so an average in this case, we don't know of what, but just 412.8 to 422.3. That's our list of plausible values. So from this, we have to extract from that x bar plus or minus the margin of error. Now, we talked a little bit about this before break, where the statistic itself is just going to be the middle number in here. So if you want to get your statistic out of this interval, we just have to find the middle number. And we can do that by taking the average of the numbers that they give us. So we're going to average these two, which just means add them, divide by 2. So 412.8 plus 422.3 divided by 2. That gives me 417.55. So this is my x bar. Okay, and then the margin of error is how far do I have to go from my middle, this x bar, to the outside, being either 412.8 or 422.3. And so the way I figured that out is I just find the difference between them. And you can do this with either one. You might just want to pick whichever one you can remember best to do or is easiest for you to do. I'm going to do, let's see here. Let's do my x bar minus my low number. And that gives me 417.55 minus 412.8 gives me 4.75. That's my margin of error. So altogether, I combine these, and I get that my confidence interval is 417.55 plus or minus 4.75. Okay, so let me try example 4. I'll put solutions to this online so you can just check what you get. But what you'll need to do, I mean, you don't technically need to do this, but what might make it easier is to convert everything to decimals here first. So then if you're going to do this work, convert these to decimals and try to do the same thing we just did. So that will be posted on Blackboard. Every example I don't do here will still be posted. Okay, so the real meat of this section then is how do I find confidence intervals? Well, 3.1, so review this if you don't remember it. We saw how to do confidence intervals. So just as an example, if I want a 99% confidence interval, then I'm checking an alpha level of 0.01. That means if I get a p-value, so let's redraw that little diagram. If my p-value is here, up here, it's bigger, then that means plausible. If it's lower, down here, then that means I reject that, that null. So if my p-value is bigger than 0.01, I'm going to say, okay, maybe that could happen. I'm okay with that. If it's less than 0.01, I say, okay, well, that was enough evidence. Let's reject that null. So we had just done this together. We go over to the table. I see 0.007. So right here, well, that is less than 0.01, so I rejected. 0.012, whoops, 0.012, well, that's bigger than our alpha, so I say plausible. And then I get another plausible, and then all the way down, plausible, plausible. They're all bigger, all bigger, all bigger, and eventually I reject again. So then here, I would say my plausible values are, for 99%, are 0.46, and then the last one was 0.59. That would be my confidence interval for the 99%. And then the only thing I have to do different for 95% is instead of 0.01, my alpha is 0.05. So now I'm just asking, is my p-value bigger or smaller than that alpha? So let's talk about the two other ways to do this. So the first one is the 2 standard deviation method. Now this method only works, so let's write that out, only works for 95% interval. All right, and it's because of this number 2. So this only works from the 95% interval, and the gist of this method, the idea of it is, and it's written right here, about 95% of the statistics we get from samples will be within 2 standard deviations of the true population parameter. So I know that's a big statement to take in, but remember we had started working on this even before confidence intervals, where we talked a little bit about how when we had these samples, they all kind of started these simulations looking like this, right? They all had this bell shape, this mound shape. Every time we ran a simulation, boom, we got this. And I know it didn't look like this. There were lots of little dots in here, each one of these a different sample, right? So maybe we put 1,000 into the computer. Okay, so that's what we were dealing with. Now, what we started to notice was, if I am right here, maybe this is my null hypothesis. This was my null. So maybe it was a coin flip and it's 0.5, or rock, paper, scissors and it's 0.33. Whatever it was, that was here. What we noticed was that if I go 1, 2, and 1, 2 standard deviations away in both directions, so this is -2 standard deviations and this is +2 standard deviations, then I will have gotten about 95% of all of the statistics, all the data points in there. I will have gotten that within this 2 standard deviation range, right? So for practice on that, go back to the homework, the online homework where you guys were practicing a bunch of those. You did a good job on those. And the whole point of doing that was to get you comfortable with that calculation, because what ends up happening is that range that you create when you go 2 standard deviations up and then 2 standard deviations below, that is just the confidence interval. That's it. So to create a confidence interval, what you can do is you can take your statistic, you can add or subtract to it 2 times the standard deviation of this null distribution. So be careful. It's the standard deviation of this null distribution, right? Not just of one sample if it's a mean. It's of many, many, many samples. So you guys have actually already done this before. It's super nice, which means that a confidence interval you can actually write as stat minus 2 standard deviations, comma, stat plus 2 standard deviations. All right. So boom, there you go. So we can do an example of this to kind of show you what things are going to look like. So if we go here and we say, okay, I'm going to go onto this screen. All right, so then if we go to the 1 proportion inference, okay, we're going to leave it at 0.5 for right now, and we can talk a little bit more about why. The number of tosses, so I'm looking at this example here, and it says 1,034 random U.S. adults were surveyed. So that gives me my sample size. Let's do 1,000 number of repetitions. I'm going to get rid of animate. I'm going to draw my samples. Okay. So this is my null distribution, and again, notice that this looks like a bell shaped. It's not perfect, of course, but it's pretty good. Okay, so then what I'm going to do is I'm going to click Summary Stats right here. And when I click this Summary Stats, I'm going to get what the standard deviation and the middle are of this. But all my information is in terms of an actual proportion, a percent. So I'm going to click this Proportion of Heads button, and here's what I see. So I have a mean of 0.5, because that's what I told the computer right here. This is like a coin flip, okay? And then all I have to do is I write down the information I know. So I go back to the example. 69% said it had no effect. So that's 0.69. That's my statistic. Plus or minus 2 times, and then my standard deviation is right here, 0.015. 0.015. Okay, so then I'm just going to type that into my calculator. Remember, this is the minus, comma, the plus. So that's 0.69 plus 2 times 0.015. Okay, so then when I did the plus, I ended up with 0.72. And if I do 0.69 minus 2 times 0.015, I'm going to get 0.66. So that is my confidence interval. Now, what could we have done here? Oops, I covered up everything I did. So you can see the calculation there. So what could I have done here instead? If this was back in section 3.1, then what I would have done is I would have kept testing everything. So 0.69 I would have put in my count, right? And then what I would have done is I would have kept testing different nulls. So okay, 0.5, I get a p-value of 0, reject it. Let's get bigger. So how about 60? So let's reset, let's count. Oh, still 0, reject. So I would have kept getting bigger. Let's go 5. Draw my samples. In this case, 0.05, I have a p-value now, it's not 0, but it's still really small. Reject. So keep getting bigger. Okay. I go up one more. Whoops. I draw some samples. Oh, I'm getting a little bit closer now. I'm getting bigger. So I go up a little bit more now. So let's go 7. Maybe we can even go 8. Draw my samples. Oh, that was too big. So let's drop down. I'm gonna say that's plausible. That's right on the borderline. So 0.67, I technically would say plausible because this is above 0.05, but it's right on the border. So what I could try to do is 0.65, or sorry, 665, because I want to split the difference there, and I could draw those. And okay, that's reject. So it's around 0.66, 0.67. But you should think about how crazy this was. I didn't do any simulations to find this, right? This is me just playing around with the simulations and trying it out. But my answer with just using this quick little formula was 0.66. What I'm seeing here is that I could run these simulations, thousands of samples over and over again, and I'm still going to get right about that 0.66. So it's not perfect doing it this way. The number 2 is actually an approximation. The real number theoretically is 1.96 to use for this number right here, but 2 is pretty good, so that's what we're going to use for this. So it's not perfect, but it does a really good job. Okay, so then we go to number 3, and we say, I don't want to do any of this computing anything, so we go to theory-based inference. I go confidence interval. I'm going to put in my information, 0, 1, 3, 4. Am I remembering that correctly? Yep, 0, 1, 3, 4. That's how many I had. My sample proportion was 0.69. That automatically does the count for you. So remember, all you have to do is put in 2 pieces of info, the sample size and either the count or your p hat, and it'll tell you everything else. Okay, so do a little calculation, and then boom, immediately confidence interval pops up. immediately 0.6614 to 7178. So let's just double check how close that is to what we got with the 2SD method. 0.66, yep. 0.72 with a little rounding, exactly the same. So this is really just using a formula very similar to this, except it's trying to approximate the standard deviation, because it didn't run a simulation to do this, right? So if we go back to our work, we had to run a simulation with the other applet to get this SD here. This theory base is taking it a step further and saying, nope, you don't even have to do that. I'm going to give you one formula to try to predict this. And look at how close they are. 0.66 to 0.72, and then look at this. I'm right on it. So I'm giving you all this crazy stuff, but I'm not telling you the actual formula. Well, the formula we've actually already seen before, something very similar. So the formula here would be p hat plus or minus. Now the margin of error is 2 times the standard deviation of the null. But you already practiced doing that. We already talked about how we could predict that. We predict that in the theory-based using the formula pi times 1 minus pi over n. And so we've already done that before. We had you do this computation. You've already seen this idea. Pi in this case, do we know pi? No. If we knew pi, why are we doing statistics? So we've done a couple things here. One thing we've done is said, well, we could just use our statistic, right? Because our statistic's supposed to be, it's supposed to be close to the right answer, pi, but it might not be perfect. So, that's one option for you to use. If you have some knowledge beforehand of what pi might be, and your statistic kind of, seems to fit that, you can try to use that. If you have prior knowledge of what pi should be, like previous studies, you can use that number for your actual pi in here. If you don't know, or you want the most conservative thing you can get, and by conservative I mean, you're building into this as much kind of I could be wrong as possible. So your margin of error, you're getting that as big as you possibly can be to just kind of be on the safe side. What you can do is pick, what you can do is you can pick pi equals 0.5. We could convince ourselves, which isn't too much work, that picking pi equals 0.5 will be a perfectly fine thing to do and give us the most leeway possible. So if you're not sure, just go pi is 0.5 in this formula. But that's it. That's the formula that they're using to get an answer that looks very similar. And so, there's a couple things to think about here. One, when can I do this? When am I able to use this theory-based? And it's the same conditions that you've used before. When could you use the theory-based for a hypothesis test before? And it's the same exact conditions as before. We need 10 successes and 10 failures. If you can check these two boxes, then we're going to be good to go to use this formula. Just here's my information, throw it in the formula. I can give you a confidence interval, no other work necessary. So pretty amazing, pretty nice, but again, we really only want to rely on this if we've hit these boxes, that we've checked these boxes for the theory-based. Okay, so let's try an example with this and see where we can go. It says in a random sample of 1,011 adult Americans were asked if they consume alcoholic beverages. 647 of them said that they did. So it says, use the 2SD method to find an approximation of the 95% confidence interval by hand. Write the interval in both notations. So, first things first. The question was, do you consume alcoholic beverages? I see that as a yes-no question, which means this is categorical, which means I'm dealing with a proportion. So, the 2SD method is p hat plus or minus 2 times the standard deviation. Okay, so 647 out of the 1011 number of people, that's my p hat, plus or minus, whoops, sorry about that, plus or minus 2 times the standard deviation. Now in this case, to find the standard deviation, I'm just going to use the applet. So I'm going to go over here to the applet. I'm going to reset everything. So I don't know what the correct answer here is, so just to be safe, I'm going to do 0.5. My sample size was 1011. Okay, my number of repetitions, we can keep that 1,000, that's fine. Let's draw some samples. My standard deviation is 0.015. So I'm just going to read that right off, 0.015. And then I'm going to throw this all into a calculator. So I'm going to end up, and I'll do this in pieces, 0.46 divided by 0.1011. So that first piece is 0.64, and I'll just round it there, plus or minus 2 times 0.015 is 0.03. Okay, so boom. That's one way to write the confidence interval. The other way is to do 0.64 minus 0.03, which is 0.61, and then 0.64 plus 0.03, 0.67. Confidence interval. That's all there is to it. So just as a reminder, this from the applet. Okay. Write a complete sentence to interpret the meaning of the confidence interval in context. So then we can start these always the same way. It's so great. In this case, this was a 95% confidence interval because we're doing the 2SD method. So we are 95% confident that the proportion, because that's what we were interested in, of adult Americans who consume alcoholic beverages is between 61% and 67%. So let's stop here and think about a couple things. First of all, it was a 95% confidence interval, so that's what I start with. The next thing is I mention exactly what I'm thinking about in terms of my my parameter. It's a proportion of adult Americans. So I go up and I have to look and say, well, who did I actually ask? Adult Americans, okay. Now, what did I ask them? Do you consume alcoholic beverages? That's right here. So that's the next piece. Now, again, I'm giving an interval. I'm giving a range of possible values. So I'll never say it is blank. I'm always going to say is between or is in something. So the proportion of adult Americans who consume alcoholic beverages is between 61 and 67%. So I'm not 100% sure on that. I'm 95%. But I'm pretty sure it's somewhere in there. Okay, so now it says use the theory-based inference applet to get the 95% confidence interval. Okay, so let's use this applet. Let's duplicate this so I don't have to keep looking, going back and forth. All right, so I had 1011 number of people. Let's see here, my sample proportion, or just my count, that would be easier, was 647. So I'm just pulling that from right here. That's my count. Okay. So then I go to confidence interval. I just double check that this is 95%. And here's my confidence interval. 61 to, looks like 67%. Okay, well, let's scroll down and I look, 61 to 67, 61 to 67, check. So all I'm going to write for this next piece here, so let me scroll over, is, I'm just going to write down the answer I got. So I got 6104, comma 0.6695. There you go. Whee. Okay. So then it says, use the theory-based inference applet to get now a 99% confidence interval. So this does not work with our 2SD method, the one we just used. But what we can do is just turn that into a 9 and recalculate. And so what we get is 0.6011 to 0.6788. Okay. So then we can now write this in the other notations. This is good practice. Remember, we're trying to do stat plus or minus margin of error. So I'm going to find the middle number. P hat will be equal to, let's add these and divide. So let's plug that into our calculator. 0.6011 plus 0.6788 divided by 2 is 0.63995, which we'll just round to 64, which actually is our statistic. Perfect. And then the margin of error will be the difference between that and one of the edges. So then find the margin of error. I'm just going to do my 0.64 minus 0.6011, 0.64 minus 0.6011, which gives me 0.0389. So another way to rewrite this would be to write it as 0.64 minus, oh, I did it again, didn't I? 0.64 minus plus or minus 0.0389. All right, boom. We got it. Okay, so one of the next key points of this section. So the E and F are the two big, I would say kind of tough, really thought-provoking ideas in this section, right? Everything up to this point has just been, you know, plug it into something, plug it into something, plug it into something. But these are the really big ones. So E, is the 99% interval wider or thinner than the 95%? So let's check it out. 99%, 95%. Okay, so looking at these two, how do I figure out what's wider? Well, I just can look at the bottom numbers if I want. So I see 0.61 and 0.60. So if I was to put this all on a number line, I would put 0.61, and then all I got to do is say, okay, 0.60, is that to the left or right? Is it smaller or bigger? Well, actually, it's smaller. All right, well, let's put down the other piece of the 99%, 0.6695. All right, is 0.67 bigger or smaller, right or left? It's on the right. It's bigger. So what I end up seeing is that my 99%, that's here, is bigger than my 95%. That's just this middle one. So that's in red. All right, so I got wider. So we got to think about this. Why should it be that if I'm more confident, I have to give you a larger range? So think about that. I'm more confident. I think sometimes your gut reaction from that can be, okay, I'm more confident, so then I did a better job. Well, this is an unknown thing. So to be able to tell you a range of values that I really think the answer should be somewhere in here, if I'm going to be more confident about that, I've got to give you a larger range. In order to be more confident that I've given you the right number somewhere in there, I've got to give you a wider selection of numbers. So let's think about it this way. If, I don't know why this is the one that popped into my head. If I was going to try to guess someone's weight, if I said something to them like, you know what, I'm going to guess that your weight within 1 to 2 pounds. Well, that would be really tough, and I would not be very confident about being able to do that. But on the other hand, if I was to instead say, I can guess your weight within 15 pounds, plus or minus, well, I would be more confident that I could do that. So to increase my confidence that I can actually do this correctly, guess someone's weight correctly, I'm going to give myself more leeway. That's exactly what's happening here. So try thinking about that idea, try convincing yourself about it, and please ask questions if you're not sure. You can email me, you can come to the Zoom office hours, you can post in the discussion forum, and the other students, myself, we can talk through it. Okay, the other big idea here. Tony claims 70% of all adult Americans consume alcoholic beverages. What do you think of Tony's claim? Okay, so I've given you what I think I'm pretty confident about are the range of the true proportion values. So if we go to the 95%, that was 61% to 67%. Okay. Now if I go to the 99%, that was 60% to, we'll round that up to 68%. Okay. So, first glance at this, where is 70%? 70% is not in either of these. It is not in the 95 or 99. Remember, both of these we were thinking of as the plausible values. So when Tony claims that 70% of all adult Americans consume alcoholic beverages, his 70% is not one of our plausible values in either of these scenarios. So we think Tony is wrong. But there's a caveat here. We've got evidence towards him being wrong, but we can't 100% say Tony's wrong. We just think it's extremely likely he is wrong. But he could be right. It's possible, but probably wrong. So you could tell him that. Okay, so that was a lot. I know this is a lot of stuff. What I'm going to do for the rest of this is just upload the solutions. I know, again, there's a lot of these, but I just want you to get a lot of practice. They're all very similar, so you can kind of see how they all go. I'll put the solutions to this on Blackboard. Go work on them, try them out, and let me know if you have questions. So the couple things just to remember that you've got the book, you can read the section. I've picked out specifically the videos that you should be watching for this, so you can go through and watch the videos instead or in addition to. You can ask me questions, anything you want to use. You can find any online resources. You can work with each other. Please talk to each other over email. As a campus, we're going to be using Zoom a good amount. And so we're going to be testing this together next week as a class, but feel free to be using that to work with each other. Zoom works pretty well on phones, so you've got that option. Please ask questions if you have any, and I'll see you in the next video.